Hello, this is Mr. Best. Welcome to the closure questions from Chapter 8, 112 to 122. Factor and use the zero product property to find the roots of the following quadratic equation. Once again, remember the word roots. We're looking for where the graph crosses the x-axis. So we're looking for the x-intercepts, also called zeros. So on A, we have 0 is equal to x squared minus 7x plus 12. So on these problems, I'm not going to go through and do all the generic rectangles. I'm just going to go ahead and write them in the factored form. So this would be x minus 3 and x minus 4. And then we can use the zero product property and set our factors equal to 0. So x is equal to 3 and x is equal to 4. We're going to add 3 and add 4 to both sides. And so therefore we have our roots. So x is equal to 3 or 4, and once again you could write that either way. So we can do this way or this way. B, 0 is equal to 6x squared minus 23x plus 20. So don't have any common factors involved. So I think on this one I'm going to have to use the generic rectangle here. We have 6x squared and 20. So that means we're looking at factors of 120x squared that are going to add to give us negative 23. So go through your factors of 120. There's a lot of them. Eventually, hopefully, though, that you're able to see that negative 15x and negative 8x will multiply to give you 120x squared, and they add to give you negative 23x. And so we'll plug these into our generic rectangle and then write our dimensions here. We got 3x and 2x is where I'm going to start. We'll see if this works out. This would then be a negative 4. 2x times negative 4 is negative 8x. And then 3x times negative 5 is negative 15x. And then check your last one to make sure it does give you 20 down here. Negative 5 times negative 4 is 20. So it looks like we're good. So 0 is equal to 2x minus 5 and 3x minus 4. Set our factors equal to 0. Add 5. Divide by 2. That's 2.5 or 5 halves. Add 4. Divide by 3. And I'm going to have to leave that one as 4/3 because the decimal repeats. So we have x equals 2.5 or x equals 4/3. Or once again, we can write it as a set 4/3 or 2.5 or 5 halves. Alright, example C. 0 is equal to x squared minus 9. That is one of our special quadratics that we can factor using difference of squares. The first and last terms are perfect squares. And you're missing your middle term because it cancels out. And you have a minus 9, so we got x minus 3 and x plus 3. And then we set those factors equal to 0. Add 3. Subtract 3. So x equals 3 or negative 3. Or we can say x equals our solution set negative 3, comma 3. Alright, on to D. We have 0 equals x squared plus 12x plus 36. This is a perfect square trinomial. The first and last terms are perfect squares. And then when you take those perfect squares and times it by 2, the product times 2, you get 12x. So to show you this works, this means that we take the square root of x squared, which is x, and the square root of 36 is 6. So once again, your middle term should be 1x times 6, and then you double it or times it by 2, and that's 12x. So that does work with this problem. So it's a perfect square trinomial. So it looks like we're only going to have one answer because the factors are the same. So when you solve both of them, you solve them the same way, and you get the same answer, negative 6. So x is equal to negative 6. And so that's how you factor and use the zero product property to find the roots of quadratic equations. Question 113. The price of milk has been steadily increasing 5% per year. If the cost of a gallon is now $3.89, we have two questions to answer. What will it cost in 10 years? And then what did it cost 5 years ago? So for each of these, we need to be able to find that equation. Now, if it's increasing 5%, so that means we're starting at 100%, and we're adding 5% to that. So our multiplier would be 105% or 1.05. And our initial value of the milk is $3.89, or at least right now it's $3.89. So we can say that the equation is y equals $3.89, and it will be multiplied by 1.05 every single year to show that increase. So now that we have that, we can go back and answer part A, which is what will it cost in 10 years. So we can plug 10 in for x, because that represents the number of years. So plug that into your calculator and round to the nearest cent. And I got a value of 6.34. So that means in 10 years, the milk will cost, or is predicted to cost, $6.34. All right, and then for part B, what did it cost 5 years ago? So now we're going back in time to see. So x would be, since we're going 5 years ago, we need to do that as a -5 and plug that in and see what we get. And if we round it to the nearest cent, we get 3.05. And so 5 years ago, we predict that it cost $3.05. And so once again, make sure you guys write those answers out and you label them accordingly. Question 114. Use the graph at right to answer the questions below. One of these lines represents Feng and one represents Wei. Write an equation for each girl's line. So what we need to look at is what the y-intercept is. So we'll start with Feng, and hers crosses the origin. And then we want to find another nice point so we can figure out what the slope is and draw the slope triangle in. So that's 6 up. And make sure you're looking at the axes. This represents 1 unit right here, so they're labeled differently. And so it looks like it's going over 1.5. So if I go up another 6 and over, that might give us a triangle without decimal. So it'd actually be going up 12 and over 3. So for hers, we have y equals a slope of 12 over 3. So it's rising 12 over 3, which we can simplify, and then plus 0 for the y-intercept. So y is equal to 4x. For Wei's, let's take a look. So the y-intercept is -12. And this one looks like we can go up 6 and over 1. So that'll work. So y is equal to 6x, and then the y-intercept was -12. So that is part A. B, the two girls are riding bikes. How fast does each girl ride? So we'll just write the answer next to their equation. That represents the slope, and so when you're paying attention to the slope, you have the distance from the school in miles, and then the time in hours. So the rate of change is going to be miles per hour. So Feng is going to be riding at 4 miles per hour, and Wei will be traveling at 6 miles per hour. And that is part B. And let's go to part C. When Feng and Wei meet, at what point, how far are they from school? So when they meet, looks like right in here, this will tell you that it took them 6 hours, and then the distance looks to be 24 miles from school. So we need to write both those things down for part C. That they met after 6 hours and 24 miles from school. So Feng and Wei met at 6 hours and 24 miles from school. Question 115, graph y equals x squared minus 2x. Identify the y-intercept, the x-intercept, and the vertex. Now, we've done this a lot of different ways, so what I'm going to do might not be the same thing you did, and that's perfectly fine. To find the y-intercept, we can start by plugging in 0 for x squared. And there is no constant, so it's 0, so therefore the y-intercept is going to occur at 0, 0, which will also represent one of our x-intercepts. So to find the x-intercepts, or the roots, I'm going to set 0, y equal to 0, and factor the quadratic. And I can factor by factoring out a common factor of x. And so I can see that one of my factors is going to be 0. And the other one, x minus 2, will equal 0. So there's the x equals 0. That gives you your x-intercept at 0, 0. And then when I add 2, I get my x-intercept at 2, 0. All right, which actually allows me to find the axis of symmetry, or the line of symmetry, because between those 2 points at x equals 1, we know is where the parabola will be symmetric. So then the last thing we need to figure out is the vertex. And we can do this a couple of ways, but since I know that the vertex is going to occur at 1 something, I'm going to go ahead and solve for y by plugging 1 in for x. And that gives me 1 minus 2 is negative 1. So at 1, negative 1 will be the vertex. And so with those 3 points, we can go ahead and sketch the graph. To find the vertex, also, we could have completed the square on y equals x squared minus 2x, and that would have also allowed us to find the vertex. Question 116. Find the coordinates of the y-intercept and x-intercept of y equals x squared minus 2x minus 15. Show all of the work that you used to find these points. So on this one, we can start once again with the y-intercept. Because it's in standard form, it is easy to look at it and identify what the y-intercept is, because when you plug in 0, it's going to cancel the first 2 and just leave you with your constant at the end. So therefore the y-intercept would be at 0, negative 15. On the x-intercept, we're going to take the problem and attempt to factor it to see if we're able to find the x-intercepts that way. And so if we factor it, we set y equal to 0, and once again you can use your generic rectangle, and this one can be factored to x minus 5 and x plus 3, so therefore we will be able to find the x-intercepts because it is factorable. So x is 5, and then x is equal to negative 3. So our x-intercepts are at 5, 0, and negative 3, 0. And I believe that is all that it asks for. So find the intercepts, and to show work on the y-intercept, if we do need to show work, this would be y equals 0 squared minus 2 times 0 minus 15. That's y equals the negative 15. Question 117. Without using a calculator, simplify using only positive exponents. So in part A, we have 9 to the 1/2, which represents the square root of 9, x squared times y. Then we have the cube root of 27, and then y raised to the negative 1. So we can simplify this. The square root of 9 is 3, x squared y. The cube root of 27 is 3. And now we can multiply the 3 times 3 to get 9. There's only that one variable of x, but it's being squared, so that's x squared. And then y to the first and y to the negative 1 would be y to the 0, and anything raised to the 0 power is 1. So we get an answer of 9x squared. Part B, we have x raised to the 1/2 raised to the negative 2. So you could approach this a couple of different ways, but since you have a power raised to a power, we can multiply those two, and that would give us x to the negative 1. And since we have a negative exponent, we can rewrite it as the reciprocal, 1 over x. On part C, we have 1 over 125 raised to the 2/3. So since it's raised to the fraction 2/3, we want to rewrite this so that it's raised to the 1/3 but then taking that, what would give us 2/3? Well, then that would be 2. So 2 times 1/3 is 2/3, but we can rewrite this as the cube root of 1 over 125 squared. When you have a fraction that you're trying to take the cube root of, you can take the cube root of both parts. So the cube root of 1 is 1, and the cube root of 125 is 5. So that would be 1/5, because 1/5 times 1/5 times 1/5 is 125, and then you can square it and get 1 over 25. And then the last one on D, we have 8x to the third power over negative 2x to the negative 2. So the 8 divided by negative 2 is negative 4. And then you can either subtract the exponents or use the reciprocal for x to the negative 2. I'll just go ahead and subtract. What is 3 minus a negative 2? And 3 minus a negative 2 is a positive 5. So we have an exponent that's positive. I don't have to worry about any negatives on that one in terms of moving anything around. So I think that finalizes this question. Question 118. Quinn started off with twice as much candy as Denali, but then he ate 4 pieces. When Quinn and Denali put their candy together, they now have a total of 50 pieces. How many pieces of candy did Denali start with? So it looks like on this one we're going to need to write some let statements as to what variables we are going to use. So let's let D equal the number of pieces of candy for Denali. And we can also let Q equal the number of pieces of candy for Quinn. Now, Quinn started off with twice as much candy as Denali. So Quinn started off with twice as much. So if we take Quinn, he is going to equal 2 times as much candy as Denali. So if you take twice Denali's, you're going to end up with Quinn's. But then he ate 4 pieces. Once he ate 4 pieces, they had a total of 50 pieces. So, who ate the 4 pieces? Quinn. Quinn started off with twice as much candy as Denali, but then he ate 4 pieces. So Quinn ate 4 pieces. So now Quinn has 4 less pieces. So if you take that plus Denali's, we should get a total of 50 pieces. So we're being able to set up a system, and then we can use substitution to plug in 2D for the variable in the second equation of Q. So, because twice Denali is equal to Quinn. So 2D minus 4 plus D is equal to 50. Combine your like terms. Add 4 to the other side. And then we can divide by 3. So D is equal to 17. Or not 17, how about 18? Now, it doesn't ask us to find the number of pieces for Quinn, but we could easily do so because we could multiply it by 2 and get 36, which would be a total of our 50 pieces. Well, I guess he had 36 originally, and then he ate 4, so he had 32 at that point. But anyways, how many pieces of candy did Denali start with? Denali started with 18 pieces. Question 119. Given the 2 points, what is the equation of the line passing through the points? And then is the point 5133 also on the same line? So to be able to write the equation, given 2 points, we want to find the rate of change. So we can take 25 minus 7 divided by 30 minus negative 24. So this would give us 18 divided by, and since it's minus a 24, you can add, that would be 54. And that will reduce to 1/3. So that's the slope. And then to be able to write the equation, I still need the y-intercept. So we can take one of the points, I'll take the second one, plug in 25 for the y, 1/3 for m, and then 30 for x, and then add b, and then we can solve. So 1/3 of 30 is 10, subtract 10, and we get b equals 15. So we're able to write the equation y equals a slope of 1/3 times x plus a y-intercept of 15. Now in part B, it wants to know if the point 5133 is on the same line. So we should be able to plug in the information given to us and see if we get a true statement. So does the right-hand side equal 33? A third of 51 is 17. 17 plus 15 is very close to 33, but it is not 33, it's 32. So therefore, the point 5133 is not on the same line. So make sure you explain your reasoning. Question 120. Write the equation of the following two sequences in first term form. On part A, we have 100, 10, 1, and 0.5. So what is the pattern? How are we going from 10 or 100 to 10 to 1 to 0.5? Well, you can tell it's not addition and subtraction. It's fallen too quickly at the beginning, and at the end it gets a little bit closer. So let's look at multiplication. What multiplies to give you 10 from 100? Remember, we can also work backwards to say 100 times what gives you 10, and then when you divide by 100, you see that x is equal to 1/10, or 0.1. And then 10 times 0.1 is 1. 1 times 0.1 is 0.1. So first term form, we don't have to go back and find term 0. So we're going to go ahead and say t of n is equal to the first term, which is 100. The multiplier is 0.1. And then remember, we're going to raise it to the n minus 1 power. Now, on this, it wants the first term form. If we wanted to write it in the other form, just to kind of give you an idea that it doesn't really matter in terms of what form we use, we would have to go back to term 0, so that would be 1,000. Multiplier is still 0.1, but then you would raise it to the n power. So when you plugged in 1, on the bottom one, you would get 0.1 times 1,000, which is 100. Where on the top, if you plugged in 1, you would get 0. And then anything to the 0 power is 1. 1 times 100 is 100. So once again, it works either way, but this technically is first term form. B, 0, negative 50, negative 100. So on this one, we subtract 50, and so on. So we will use first term form again, and this would be an arithmetic sequence because we have a common difference of negative 50. So we start with the first term, which is 0, and then we're going to add negative 50 in. So I'm going to write negative 50 in, and then usually we would say we started at 0. Now obviously the plus 0 doesn't necessarily matter in this problem. And then, oops, made a mistake. Let's go back. Or no, that was fine. Negative 50 times n minus 1, because we're doing first term form. I apologize. There we go. And then the plus 0 now, that plus 0 doesn't necessarily matter. So negative 50 times n minus 1. And then if I wanted to do it the other way, I would still do the negative 50 times n, but then I would have to work backwards and add 50. So it would look like that. So once again, first term form is the first one here. I apologize for the confusion. And then the second one would just be the form that we've been using before, but we'd have to go back and find term 0. Question 121. Write the first 4 terms of the following sequence. So on this one, they're using the a sub n form. And so that's just saying in terms of whatever term we're looking for, a sub n is equal to 3 times 5 raised to the n minus 1. So if we wanted to find the first term, we just plug 1 in for n. So 1 minus 1 is 0. So we have 3 times 5 to the 0 power, which is 3 times 1, and that is 3. That's the first term. Now, we don't really need to keep plugging these in because we can see by the sequence it's geometric and each term is getting multiplied by 5 each time. And so now we can just take 3 times 5 is 15. 15 times 5 is 75, and 75 times 5 is 375. Now, technically, I didn't have to go through and find the first term because it was already given to you in the problem. So if you recognize that, you can just start with 3 and then multiply by 5 each time. That is in first term form. So that's kind of up to you on how you want to look at that. On B, it's telling us a sub 1 is 10. That means that the first term has a term value of 10. And then the a sub n plus 1 is telling you that the next term will be in the form of negative 5 times the previous term. So the first term is 10. The next term gets multiplied. To get the next term, you multiply the previous term by negative 5. So that would be negative 50. Multiply by negative 5 again. You get 250, and then multiply by negative 5 again. And that's negative 1,250. So that is the recursive form that is given to you. And then so you're using the previous term to find the next term. Question 122. Bianca plays lacrosse for her high school team. She loves to look at the ratings of lacrosse teams that play in her area. She wondered if she could predict the differences in the final scores when two teams played each other. Bianca looked at the differences in ratings and scores between different pairs of teams and drew the following scatter plot by hand. Discuss the association, including an interpretation of slope and r squared. So you can tell with the information given, the x-axis represents the difference in the ratings, the y-axis represents the difference in the scores. We also have the scatter plot here. You're given the r value is 0.9, but it looks like that's all you're given. So we are going to have to use a calculator to figure out the rest of the stuff. By plugging the information into the calculator, you will get a least squared regression line. That will approximately be y equals 1.6x. So we need that to interpret the slope. And we have the r value, 0.9, so that we can figure out what r squared is. So go ahead and look at the answer key. I'm not going to type all this up on here, but go ahead and look at the answer key to the closure problem. And it does include, since r is 0.9, that we are going to have a very strong positive linear association between the differences in ratings and the corresponding difference of the game scores. There is no apparent outlier, so we don't see anything too far away from the line of regression. And about 81% of the variation in score differences is explained by the difference in ratings of the two teams. Now remember, where we get the r squared is from the r value that is given, 0.9, and we square it. So that's why we get the 0.81, which is 81%. The slope is about 1.6, and so therefore we have an increase of 1 in the difference of ratings is expected to increase the score difference by 1.6 points. So once again, an increase of 1 in the difference of rating is expected to increase the score difference by 1.6 points. So once again, the answer key is in the closure at the bottom, so you can read through that interpretation of the slope, the r squared, and discussing the association. On part B, predict the outcome of a game between Novato and Marian Catholic, and it gives you the two ratings. So we're going to figure out what y is, that's the difference in the score, is equal to 1.6x. But remember, x is the difference in the ratings. So we need to subtract 74.27 minus 76.61 and plug that into the calculator and see what we get. And we get a value of negative 3.744. So since we have negative and we started with Novato first, then it looks like they're going to end up losing by about 4 points, or Marian Catholic will win by 4. And the last question, part C. The difference in rating between Woodbridge and Lakeside was 5. When they played, the residual was 7. What was the difference in their scores in this game? So the difference in rating between Woodbridge and Lakeside was 5. So what does that mean? Well, we have the x value, because that's the difference in the ratings. So we'll take 1.6 times 5, and that'll give us a y value of 8, which is 8 points in terms of the difference in score. When they played, the residual was 7. So since we know the residual is equal to the actual minus the predicted, the residual is 7. The actual we don't know. And the predicted we found was 8. So if we solve for the actual, we get a value of 15 points. So what was the difference in their scores in this game? The difference of their scores was 15 points. So I think that finishes up question 122. Good luck on your Chapter 8 test.